Hi there, this is our last little video on naming. So I'm hoping you're understanding and are able to do the work that we're talking about in naming. We have the more you do it, the better off you're going to be. So I'd recommend you do as many naming problems as you can to get get used to it. It's not easy. It's just like learning a new language. So don't be hard on yourself if you're think you're taking a long time learning how to name. There's just so many little rules that we have to follow. And you'll just get better and better. Just like learning any language, it'll just take you time, and the more you do it, the better off you get. So don't feel discouraged if you're feeling that way about naming. It is complicated and it takes a while to get used to. So we're going to talk about laws for formulas and names. And so this birthday cake has 1 cake, 4 candles, so it has a formula. We're going to talk about formulas in this section. So what are the 2 laws that describe how compounds are formed? We have the law of definite proportions, and we have the law of multiple proportions. And the rules for naming and writing formulas are possible only because we know that elements come together in predictable ways, and they come together always in the same formula. So you get used to it after a while. So these are the 2 laws that we're going to use, the law of definite proportions and the law of multiple proportions. So this first law says the law of definite proportions states that samples of any chemical compound, the masses of the elements are always in the same proportion. So it's like H2O always has 2 hydrogens, always has 1 oxygen. So 2 hydrogens weighs 2 grams and oxygens weigh 16. So it's always a ratio of 2 to 16. So that's the law of definite proportions, and it never changes because H2O is always that formula. So here's water, and it always has a ratio of 2 of these guys to 1 of those guys. So it's a ratio of 2 to 16. Lowest terms would be 8 to 1. So that's what we're talking about. Law of definite proportions, it always stays the same. Hydrogen peroxide is 2 hydrogens, 2 oxygens, so it has a different ratio, 16 to 1, but it always stays 16 to 1 for this molecule. So that's the law of definite proportions. The law of multiple proportions, whenever the same 2 elements form more than 1 compound, the different masses of one element that combine with the same mass of the other element are in the ratio of small whole numbers. So that sounds complicated. Let's see what that means. So if we have compound X, it's got 5 grams of A, 2 grams of B, 7 grams of X. Got 10 grams of A, 2 grams of B, 12 grams of X, for Y, sorry. So this is compound X, this is compound Y. They have this proportion of the different elements in that. So 5 to 2 to 7 in this compound. In this compound it's 10 to 2 to 12. So that's the law of multiple proportions. I don't know if I want to do the math things with you. So how do we write a chemical compound? Let's do some practice with this. We're going to follow the arrows and answer the questions on the flowchart to write the correct name of a compound. So you got a compound here. You want to know if it's an acid or a base, then you're going to go that direction. Acid is going to go that way. If it's not an acid, if you don't see the little AQ by the compound, then you're going to say, is it 2 elements? If it is, you're going to use the, if it's greater than 2, you're going to go this direction. If it's less than 2, you're going to use the binary rules where you change it to "ide" at the end. If not, then you have to figure out if it's a polyatomic and then use these ites and eights for the number of oxygens in there. If it's binary and it's got a metal, if it has a metal, then you're going to move on here, but if it's just 2 nonmetals, you're going to use the mono, di, tri, tetra, penta, all those rules for that. If it is a metal and you have a metal and a nonmetal, then you're going to use the sulfide ending. So this little flowchart, oops, we'll go back, might help you if you like that kind of thing. It might make it more logical for you than all the rules that we've been talking about in the last lessons. You might want to look here first to see what naming rules you need to use before you get started, because I know there's a lot to it. And look at all the look at all these steps on here. The first time you look at it, it's probably super complicated in your mind. So you're just gonna need to, if you're a logical kind of person, you might like this flowchart to get you going. We'll just keep working on it, plugging away all class long, and it'll start making more and more sense as we use it over and over again. And it's not an easy thing. It's just like learning a new language. So don't beat yourself up if you're having trouble getting through this. I'll work with you till we get it all straight in your mind. So remember the ites and eights. And here's some guidelines that might help. So ide means it's binary, two different elements hooked together. So that's a clue for that. Ite and eight means there's oxygen in there somewhere. Ite is less oxygen, eight is more oxygens. And prefixes means it's a molecule. So that's a clue for that. Roman numerals means you have those transition metals in the center of the periodic table, and we have to tell you what the charge is. So we have to use those for those transition elements in the center of the periodic table. So if it has prefixes, it's molecular. If it doesn't, it's ionic. And then we're going to use symbols from the periodic table. We're going to use the charges. If it's a cation in the transition metals, it's polyatomic. We have to memorize those because otherwise you're going to have a lot of trouble. So please, please, please memorize the polyatomics that I told you to memorize. And then group A elements, you know their charges from the periodic table. So these are the easy guys. These are not so easy because either I have to give you the Roman numeral or you have to find that from the name that I give you to figure out the charge. So this has to be given to you. This you have to memorize. So know this from periodic table, what group it's in. This will be given to you. This you have to memorize. So that's what you need to do. And then we have to balance the charges to make everything work out right. Crisscross method works in almost all cases unless we have to go to lowest terms. And so we always have to look to see if we're not lowest terms and fix it that way. Okay, so that's some laws, and these rules might help you. Depends on your brain if you like a flowchart or not. Some people don't like flowcharts. So let's try our quiz. So law of definite proportion says what? So it's by mass in this one, like H2O, 2 hydrogens, 2 grams, oxygen, 16 grams. It's always that ratio. So you want to write 2 chloride. So what do you think you need to know about that? We're going to need to have that Roman numerals because we have this here. That means the iron has a +2 charge. And what if you see ite and 8? What does that help tell you? So those are polyatomics, and we have to memorize those. Otherwise, you're going to have so much struggle when we name things and do math based on it, because if you don't know the ion, you don't know what it looks like. So please, please, I'm begging you, and I think it'll make your life so much easier if you memorize your polyatomic ions. And good luck and enjoy naming. I'll talk to you soon. Bye-bye.